Hello and welcome to PostgreSFM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and this is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we talking about today?
Hi Michael, let's talk about a lot of TPS we can get from a single Postgres node. I recently achieved something. I'm curious, is it some interesting achievement or no? I'm sure it's possible to get more on bigger machines because my machines were not big enough, right? It's like just 360 vCPUs and just 2 terabytes of RAM or something. Maybe 1.5 terabytes of RAM. Fourth generation AMD EPYC. There is already 5th generation AMD EPYC, and there are Intel's also Xeon Scalable, bigger instances, and so on. Like it's possible, but I've almost achieved 4 million transactions per second, full-fledged transactions, not just like what other NoSQL databases have. It's transactions, read-only. We should admit read-only. And meaningful transactions. I mean, it was a table with, I think, 10 million rows. It's a tiny table for this machine. Everything is cached, of course. And it was a primary key lookup and pgbench, regular pgbench accounts table, you know it, right? So
So is it single read
only?
Single read per transaction, single query per transaction, is that right?
That's a good question, actually. Let's double check. I will double check it right now, but I think yes, it's just select from pgbench random number, random ID, and that's it. Should be.
I was just hoping you'd get to multiply your 4 million by 2 or something. Get queries per second instead.
Let me tell you what you don't know. Yesterday I was driving to LA, and I used this, I'm thinking I should check my AI and get even more TPS. And thankfully I had AI with autopilot in car, right? So I could, maybe it's still not a good idea to use phone, but it's just quick question, right? So I asked my bot to repeat this TPS. Oh, I forgot to mention, all these experiments are done with our Postgres AI bot, which simplifies experimentation a lot. So if you need to provision huge machine, run some pgbench during a couple of hours according to some script, you just ask for it. Then you think, oh, what if we change something else? And it's just a few words. You just ask, and then it reports back in a couple of hours. So I asked, can you please check not regular select only for pgbench, which is very standard Postgres for benchmarks, quite simple but widely used. But rather, let's just use select semicolon. Not meaningful, right? Not dealing with data at all, but still it needs to be parsed, right? And so on.
I had it on my list of questions for you to ask what would happen if we got... I was going to suggest select one, which I guess is the beginner's version.
I can tell you, we exceeded 6 million. So
6 million, wow, nice.
Yeah, but it's I don't consider it fair because it's just heartbeat.
It depends what you're measuring, right? Like if you're trying to measure what's the most we can achieve, then sure, it's meaningful.
Right.
But if you're actually trying to do something meaningful, read only is probably not realistic. There's so many things you could say, and I like the idea of what's the maximum we could get if we don't worry about constraints about how realistic it is.
Right. So in this case, we only check the parser and general transaction, read-only transaction, not full-fledged transaction.
Mm-hmm.
All these pieces, but we didn't check how Postgres works with, for example, buffer pool with reading data and so on. Because I know there was some contention in the past when even for read-only queries, which was improved in I think in 9.6. On the road to achieve 1 million TPS, we will probably discuss this slightly later. But in general, what's interesting, I needed to explain. I hate select one statements. You know why, right?
No.
Because one is not needed.
Fair enough.
You can say select in Postgres. It will return you result set consisting of 0 rows and 0 columns.
Can you just run semicolon on its own or something?
Yes, you can. I think we also discussed it.
Must have done.
Yeah, it has issues, negative side effects, because for example, you won't see it in logs. if somehow it's slow, it's like empty query. You won't see it in PGSI statements, for example, unlike regular select semicolon. And I failed to convince bot to run semicolon. Somehow it didn't work. And I also had difficulties convincing bot select. It started telling me, I think it was Gemini. It was this passive aggressive manner. It's Gemini for sure. So it started telling me, like it's incorrect, it's invalid SQL statement. So let's like it offered me, let's put one at least there, like, or where's the table name? Like, okay, I said no tables, we just like idle queries, like no real action. And then it said like, let's put at least one because otherwise it's incorrect statement. I of course, like, are you sure? You can check. So we had some battle, but in general, yeah, it worked, and we achieved 6 million TPS, which was good. But semicolon didn't work for our bot. I think it's possible, and I don't expect a huge win from compared to select. Maybe it will be parser. Like, I don't know.
You could run the experiment manually, right? Could you just submit the JSON yourself?
It's better to convince a bot.
You would prefer to fight the LLM. Fair enough.
A little bit, yeah, because every time we do it, I find opportunity to improve, of course. So
fair.
But back to meaningful results, which is interesting. We almost achieved 4 million, but originally it was just 1 million. And when I saw just 1 million on modern Postgres, we checked 16 and 17 beta 1. By the way, beta 2 is already out. I think we should update and switch to it in our tests. So I expected much more because I remember the post from Alexander Korotkov from 2016 when I remember he worked with Percona people, Sveta Smirnova particularly. They had like friendly battle. Let's see what's better, Postgres or MySQL in terms of how many TPS we can get from a single node. And I think both Postgres and MySQL learned something from it. And Alexander created a few patches because some issues were found, some contention was found, and it was improved. And in Postgres 9.5 it was not so good, and 9.6 it was improved just based on this work. And he achieved 1 million TPS. MySQL also achieved 1 million TPS, good. But I was surprised, like so many years, like 8 years, right? We have so many Postgres versions, basically 8 Postgres versions already since then, and maybe 7. And much better hardware. Not much, but significantly better hardware. So I expected to get more from this.
Yeah. Well, we looked into the machines, didn't we? And they even back then they had managed to get their hands on a 144 vCPU machine. And I think you mentioned yours was bit more than double that, was it? How many was it?
360, and I think they had the Intels, much older Intels, and I had AMD, which is very easily available on GCP, which I use because I have credits there, right? So, yeah. Before we started this call, I'm like, I cannot miss this. You showed me what AWS has. Super impressive. How many? Almost 800 vCPU.
No, more.
Almost 900.
896 vCPU on one. Yeah.
And it's Intel Scalable 4th generation.
Yeah, it'll cost you.
But also 32 terabytes of RAM maximum.
Yeah.
224x large. Wow. And they don't have spots, unfortunately. Of course, this is something new. Yeah, and it's 4th generation Intel Scalable. What I found interesting, like during last year and this year, various benchmarks, not this like toy benchmark, it's a side project for me, but working with customers, various cases. What I found, what my impression right now from Intel's and AMD, like recent versions of them available in cloud, is that AMD, like for example on GCP, you can get more vCPUs and reach more TPS on very simple workloads. Right, and it will be cheaper in general in terms of how many. Like if you divide TPS per dollar, find TPS per dollar, it will be cheaper probably, and you can achieve higher throughput for simple workloads. But when it comes to complex workloads, and various problems like lightweight lock manager contention we discussed a few times.
Mm-hmm.
And in general, complex workloads and behavior of auto vacuum and so on, AMD looks less preferable, and Intel's are winning. So that's why I'm additionally impressed that AWS offers Intel scalable Xeons 4th generation, almost 900 vCPUs. It's insane for me. 32 terabytes. Wow. And you think I can exceed 4 million TPS, right? It's a joke, I guess.
It'd be interesting to hear more about what you think the current like bottlenecks are, like where you think. But I guess like my stupid brain is thinking like this is probably CPU constrained at this point. Throwing more at it makes sense that it could throw double at it. Maybe you can get close to doubling it.
Well, we collect a lot of information. We have weight event analysis.
Yeah.
We have flame graphs collected automatically for each step, and it's still it still needs to be analyzed deeper. But what I see right now, the bottlenecks are like mostly communication. Let's take a step or a couple of steps back and discuss what issues I had originally. Why only 1 million?
Can we take a step back further than that? Like, why were you doing this? Like, what's
yeah, it's a good question, and I was asking myself why do we do this? Well, for fun, first of all. Actually, I was very curious. I remember that work. I think for Alexander and Sveta, it was also for fun 8 years ago, but it led to some interesting findings and eventually to optimizations, right? So this fun was converted to something useful. And we started doing this for fun because we have like big machines, we have very good automation, we have newer Postgres. I was just curious how easy it is for us to achieve 1 million and maybe go further. And first thing we saw, since we have a very complex system, a lot of things and the observability tools, first thing we saw is that one of extensions is a huge bottleneck. It was pgstat kcache. And it even didn't let us achieve 1 million TPS, quickly showing huge observer effect, meaning that just measuring pgstat kcache extends pgstat statements to see metrics related to physical metrics like CPU, real CPU user time, system time, then IO, real disk IO, not just talking to the page cache, and context switches, and like very good detailed physical query analysis, right? And we like to have it, but if you have it until the latest versions, it quickly became huge overhead when you have a lot of queries per second for specific query.
I remember we discussed this back in. I just looked up the episode back in February about the overhead.
Exactly.
Yeah. I'll link that episode up as well.
Right, and yeah, just to recap, we found that it shows up in weight event analysis using pgwet sampling. Great, and we just quickly excluded it and also reported to the maintainers, and they fixed it in 4 hours. It was amazing. And we tested it with both, confirmed that now it's improved. So this is how we achieved 1 million. But why only 1 million? We have newer Postgres and better hardware, right? Did I answer the question why, by the way?
You said for fun.
For fun, right? Yeah, this is the key actually here. I enjoy it. But let's just run pgbench like that way or this way. Let's collect more data points. Let's visualize it. Let's repeat this, but with adjusted version. Let's compare various versions, for example, right?
So it sounds like for fun, but also like you've got credits and also dog fooding, right? Like trying out products, trying it out on here's an idea.
Yeah, we try to collect successful experiments, and we do it on smaller machines as well. But on bigger machines, we collect just to understand how system is working. Of course, we're moving towards more useful benchmarks. For example, when it will be already some specific database and specific kind of workload, and maybe not only pgbench and so on. and all the tooling will be in place, and automation is super high, so you can just talk to chatbot and get results visualized and collected with all details, and you don't miss any point. So we collect almost 80 artifacts for each data point. It's like huge. It reflects many years of experience, I would say, not only mine. For example, you can say, okay, let's compare versions 12 to 17 beta 1. This is what I did as well. And I confirmed that for regular pgbench workload, or for select-only pgbench workload, no difference. These versions are stable. No regression, but also no wins. But
12 through 17.
Yeah. But
cool.
But for select-only, this is exactly like workload which allowed me to achieve almost 4 million TPS. For this, 12 is losing significantly.
Wait. You lost me. So for read only,
no, for regular. For regular workload.
For read write. For read write.
You know, regular transactions. pgbench has, it's like, I don't know, like a couple of updates, insert, delete, and a couple of selects, and they are packaged as a single transaction, and then you just say, okay, let's just check it. And the way we check it's called like actually not load testing, but stress testing, specialized version of load testing. And we check in the edge. We say, okay, with one client, how many? 50 clients, how many? 100 clients, how many? And then you have a graph dependency of TPS, how TPS depends on the number of clients. Yeah. And it's interesting that we cannot say 0, and due to scale, we need to jump with big steps like 50. So I say 1, 50, 100, then ... 500, and the bot understands that it needs to go with 50 increments, but first dot is shifted to 1, and it's okay. So it's not like, it's interesting. Sure. It adjusts very quickly. So yeah, for fun and this, and back to versions comparison. So we found that for select only, we don't see difference, but for regular workload, and we don't get million transactions there. We have only like 30,000, maybe 40,000, something like quite lower, because it's already writing transactions and so on. We saw that 12 is losing apparently, and 16, 17 are winning slightly compared to like average for these old versions. But yeah, I think we will continue exploring and maybe test some specific workloads, not just standard ones. So.
And just to check, this is like completely untuned, like just default config.
No. Okay, it's tuned.
Great. Good to check.
Yeah, we use PostgreSQL cluster. It's Ansible playbooks maintained by Vitaly, who works with me, and Vitaly Kuharik. And it's a great project if you don't like Kubernetes, for example, and actually containers. You just need bare Postgres installed on Debian, Ubuntu, or something, and you want automation for it. This is a good project. It goes with everything, like everything most popular stuff, like Patroni, pgback REST or WolG. What else? Like a lot of simple things. Actually, even with Timescale DB, it's packaged, so you can choose to use it and quickly have it on your like cloud or self. So it's for self-managed Postgres. It's a good option.
Yeah, nice.
It takes time to install, of course, because it will be running like apt-get install, right? So it's coming with some tuning. It's similar to what cloud providers do, like 25% for shared buffers. It also adjusts operational system parameters, like kernel settings.
I guess the data set's so small that 25% just still so easily fits within.
Yeah, of course. And maybe we can tune additionally, but I didn't see the point yet. This default tuning this project provides was also like, I know it quite well because we adjusted in the past together a few times, so I know how it works, so I relied on it for now. But maybe we will additionally adjust some things. But queries are super simple, right? Data is cached, so...
I understand. I'm just trying to think like the major things, like all cached, I guess basic like write-ahead log stuff when you've got the read-write stuff going on.
Doesn't matter.
Yeah.
It does matter because we don't write. So
In one of them, in the 30,000, I reckon the 30,000 is low, and you could get much higher there.
well, yeah, if we talk about writing transactions, of course, we should think about checkpoints and so on. And it comes with some adjustments based on the size of machine already.
Okay,
so
cool.
I just relied on this default behavior. We can look further, and good thing, we consider settings as one of artifacts we collect. So for history, we record everything, all custom settings, and some system info as well. So we can revisit it later and think how to improve and next step. But bottlenecks are not there yet.
Yeah, right? So, and I was wondering, last question I had on the kind of the top line number. I get keeping PG weight sampling for being able to introspect, for being able to kind of try and work out where is the bottleneck now. It's great for that. But doesn't it also add a small amount of overhead? I know it's only sampling, so it's probably minimal. But were you tempted to try without it as well and just see what TPS you got?
I think we did, and I think it's very minimal. It's worth revisiting as well. But for now, our impression is PG1 sampling among we have. That's why, by the way, we encountered the problems with pgstat-kcache because we used basically the package we use for various kinds of experiments in the case of self-managed approach, right? So
I had them all automatically on by default. Yeah,
nice. We already had these observability tools there, and this is how we found the pgstat-kcache problem. As for PG weight sampling among all three extensions, pgstat-kcache, pgstat-statements, and PG weight sampling, by the way, both PG weight sampling and pgstat-kcache depend on pgstat-statements because they basically extend it for query analysis. They all provide query analysis. Regular pgstat-statements provides query analysis like regular database metrics like calls, timing, IO metrics at upper level, buffer pool metrics, right? Kcache goes down to physical level, CPU and disk. And PG weight sampling for each query, it also provides like profile for in terms of weight events, which is super useful. It's like different angles of analysis, right? So if you can have them all three, it's super good. Also worth mentioning, it's off topic, but interesting. Until very recently, PG weight sampling didn't register events where weight event is null, which most weight event analysis we know, like such as RDS Performance Insights, they picture it as a green area called CPU. Right, and by the way, Alexander Korotkov, who was originally the author of PG weight sampling, confirmed my idea that it's not fair to name it CPU. It should be like CPU or some unknown weight event which is not yet implemented, because like not everything is covered by a weight event analysis in the code base, right? And until recently, the PG weight sampling had a huge problem. It didn't register nulls, like naming them somehow, at least like CPU or something at all. But the guys from Cybertech implemented it like a couple of weeks ago. It's huge news. Like it's good. Thank you guys if you listen us. I'm happy that it's implemented, and I know GCP Cloud SQL also has PG weight sampling. And I like the idea that unlike in Performance Insights in RDS, we have interface to this data. Like, I mean, good interface with SQL, right? We can just query this data right from our database and build our own observability extensions or automation. For experiments, it's super important because I want to take snapshot, and it's easier for me just to take snapshot using SQL. Like, let's collect profile, like global and for per query, right? And we dump it to CSV files, basically. That's it, for long-term storage. So we quickly found Kcache, solved it, and we stuck at 1 million TPS, which made me sad because it just repeated the experiment Alexander had 8 years ago. So what's next? Do you know what was the next?
I've cheated. I've read your post already.
Right, you know.
Yeah, and I think the last episode as well gave it away with February with pgstat-statements being pgstat-statements next, right? Yeah,
huge bottleneck for such cases. I consider this edge case because
Yeah.
Normally, we don't have super high frequent query, super fast, super high frequent, and a lot of CPUs. But theoretically, it can happen. For example, you have Postgres and a few replicas, and you need to, like, you have some huge table, maybe not so huge, single index, and you need just to find records. Basically, like almost like key value approach, right? Maybe partitioned. And then queries are super fast, like a lot below 1 millisecond. So in this case, if you have a query which after you remove parameters is the same, you have single normalized query, very high frequency.
How many? There are probably only two or three normalized queries in that PG bench read-only workload.
By the way, I double checked for select only, just a single query.
Is one. Okay, wow.
All right. Yeah. It has also set this macro /set to get random, but I think it's client side, so it's not going to Postgres. It's like only for PGBench itself to generate random number. And I don't think it's a bottleneck. I hope no. Oh, by the way, our PGBench clients were sitting on the same host as Postgres, which is interesting, right? Because they consume CPU as well. And unfortunately, right now, we don't collect host stats and so on. We don't know how much of CPU was eaten. But usually it's noticeable. It's not 50% usually when you do experiments like that, co-hosting like clients and server. But I think it's noticeable. I would say maybe 20%. So if we offload them somehow, but if you offload them, you bring a network, right?
Yeah.
And we will get back to that point. So single machine, clients is on the same machine, eating some CPU. And if you have this pattern, just a single query, normalized query, pgStar statements becomes huge bottleneck. Just removing pgStar statements, we jumped from 1 million to 2.5 million TPS.
Yeah, wow.
Yeah. And then what's next? We reached 3 million. How? Let's recall. Then we reached 3 million just because I forgot originally I should use it. I remember Alexander used it in 2016. Prepare statements, right? I forgot to use it. And how did I understand that I forgot? Looking at flame graphs. Our bot collects flame graphs as well.
Nice. Yeah.
And I was inspecting flame graphs, and I just saw planning time. And I'm thinking, oh, we spend a lot on planning time, right? So let's just get rid of it. So the right way is just to say -capital M capital M prepared for PGBench.
And it's a perfect workload for it because it's simple, same query over and over again, no variance. Perfect.
Right. So, also interesting that when you, again, step back, when you see that starting from 150, 100, 150 to 200, you go to 500 clients, and you have 360 cores. And when you see it goes up till 100 or 150, and then it's plateau. It also gives you a strong feeling it's not normal, right? Because it means either Postgres doesn't scale in terms of number of parallel clients, right, to number of cores. I expected to scale on to number of cores. Of course, we have clients running on the same host, so maybe the saturation will start earlier, but definitely not at 100 or 150 if you have 360 cores. So this is how I saw, this is not right. And it happened with pgstat Kcache and then pgstat statements. Saturation started earlier. So yeah, some bottleneck, obviously. But now the curve looks already much better. It's already we reach maximum point already close to number of cores, 300 or 360, maybe 400 actually, slightly bigger. So then it doesn't make sense to increase, but we just check it, trying to find plateau. So prepare statements gave us more than additional 500,000 of TPS, right? So
I expected more actually. Only because when you're looking at super fast primary key lookups, quite often planning time is more than execution time in a simple explain analyze.
Interesting, yeah.
Yeah, so it's just interesting to me that it wasn't double, but 500,000 more is nothing to look down our noses at.
Yeah, well, interesting. Maybe I should think about it and explore additionally. But this is how it is.
Did you do force generic plan as well?
No,
Like
not yet. But
mind you, that would only like be 5. Yeah, no, that probably won't help.
here's the thing: it's in my to do maybe for this week or next when I have time. I don't have time. This is a side project just for fun and understand
Sure.
general behavior of Postgres. What I remember about this generic plan forced is that Jeremy Schneider posted a very good overview of problems others had with Log Manager recently, right? And I remember some benchmark, some specific case someone showed on Twitter. If you just tell pgbench, if you are just user, for example, alter user, and set force plan cache mode with force generic plan, it leads to huge degradation in terms of TPS. So I need to check it. And this is and lightweight log manager pops up as in top of wait events. So I need to double check it because I don't understand the nature of it. It's super interesting. But yeah,
I realized soon after saying it that the reason I thought it would help is not going to help here because you've got the same query over and over, not lots of like little different queries.
But that should be cached for sooner, huh?
Yeah, but like after 5 executions, which is probably like
it should be no difference.
Half a millisecond total.
Should be no difference in my opinion, but not degradation. Why degradation? This is
also true. Yeah, fair.
Something interesting to check, or maybe I just misunderstood. This is my to-do to clarify. So I guess it's interesting, like exploring Postgres behavior on the edge, right? So let's just recap. Like pgstat cache, we removed it, also fixed, but did we get it back? We should get it back actually, because now it's much better. They just removed some log, and it's good again. Then we found pgstat statements. Oh, so we achieved 1 million pgstat statements. We removed pgstat statements. Right, this is the key. By the way, when I say we keep only pgwait sampling, but it also depends on pgstat statements, I also feel some inconsistency in my.
I've looked it up. When you said it, I got confused. It doesn't depend on it. It's just more stuff is possible. Like
it's optional, right?
Yeah.
It can run alone, as we do right now in these experiments. But if pgstat statements is present, we can join data using query ID, right?
Exactly.
Yeah, this is good correction because I said the wrong thing. But pgstat cache does depend on pgstat statements. You cannot install it without it. This is for sure. Okay. And and these guys are not available in cloud environments. Usually, pgwait sampling is in Cloud SQL. I mean, not in cloud, in managed Postgres. pgwait sampling is available on Cloud SQL, but that's it. But maybe after this podcast, people will consider adding it, right? Especially pgwait sampling, which is really great, especially now with this fix from Cybertech. Right. So we removed pgstat statements. Reached 2.5 million. We added prepared statements, exceeded 3 million, right? And then final step, how I almost approached 4 million. It's like 3.75 million TPS. How? Like last optimization. It's actually not super fair optimization. My last optimization was let's just switch from TCP connection to Unix domain socket connection, which is possible in limited cases because it works only when you're on the same node. You should exclude network completely. And of course, like this is obvious, TCP IP connections are heavier, definitely, like more overhead than just like when processes talk through Unix domain socket. It's much more lightweight. And this allowed me to jump from 3 something to 3.75 million TPS, which is good. And also I found that 17 works worse on Unix domain socket than 16.
Interesting.
Yeah, this is also in my to-do. Why? For TCP connections, no difference. On this edge case, like select only. But for Unix domain socket, I see degradation, and it's worth exploring why. So it's maybe I found some degradation for 17. I also need
quite
to double
a big
check.
Difference.
Yeah.
Oh no! So sorry.
7 to 8%, as I remember, on higher number of clients.
Yeah, sure. Sure. I made the mistake of looking at the 17 beta chart and looking at TCP versus Unix, not 17 versus 16.
By the way, when you have when you have a long chat with bot and different different series of experiments, then you want to cross compare something. It's super easy. But you just visualize this and that on the same graph. That's it. Why not?
Much easier than getting it to give you the correct JSON I saw from the chat transcript.
Well, it depends. And Gemini is better in JSON than GPT. Well, we have a lot of fun stories. So let's not go there. But it happens. It happens. Yeah. So yeah, almost 4 million TPS for quite meaningful workloads. I think it's worth checking bigger tables, for example, to see like how it depends. For example, we can just take like 300 clients and then check, draw different picture. It's in my mind. Like, for example, let's take very small table, bigger, and huge, right? And how it will degrade, for example, right?
When you say bigger table, do you mean like 100 million rows instead of 10 million rows?
100 million rows, 200 million rows, 500 million rows, billion rows, partition, not partition. Like it's like a huge maze. You can go in many directions and turn, and then have like dead end maybe, and return and inspect another. Like it's cool. The cool thing is that I do it like anywhere. Like I don't know, like I'm eating breakfast and checking what's up with our experiments. Let's do something else. It's just my current hobby, to explore. Yeah, I think we should have more tools like Sysbench, for example, to have different kinds of workloads to be brought up to this. Yeah. So yeah, that's it. I'm very curious for selects only pgbench. Anyone had more? But now, like I was thinking, maybe it's the biggest number. It's definitely the biggest I ever saw, but I didn't see everything. Maybe someone has bigger numbers or saw bigger numbers for select only pgbench.
If they have, I couldn't find it. Like I did do some looking before the episode just to try and see if has anyone pushed it further. I did. If it's been published, I've struggled to find it.
But it's definitely possible on these huge machines on AWS, right? Because you have more vCPUs, and as we see, Postgres scales quite well in terms of number of clients and number of CPUs.
That's the direction. If you're talking about that maze, the way I would be tempted to go with this is with the currently available like cloud provided VMs, what's the most TPS I can get? I don't care about cheating. I don't care if it's only select semicolon. And I just would love to know, like, what is that number? Is it I'm guessing it's above 10 million, but is it 12? Is it 15? Like how many could we, like, that would be super interesting. How many million?
It's another good point. By the way, I forgot to mention that the problem with PG statements identified is, again, if you have like select only key value approach and you need to squeeze more, like PG statements can drop performance like 3 times here, basically. So it's worth removing it. And of course, there are already discussions. Let's mention there is a new discussion started recently, I think, by Michael Paquer. Sorry, I pronounce always wrong. How to optimize, what to do with PG statements in general. And he reacted on Twitter on my benchmark. So definitely there is opportunity here to improve PG statements. One of idea was start sampling at some point. Or
sampling is the obvious one.
Also, like, deal with high contention case differently, somehow then like update less. There are ideas.
I would hate for the takeaway here to be that there's a real overhead here of PGStat statements, mostly because this is so much the extreme version, right? This is the same query being run.
I put it everywhere. Disclaimer: this is edge case. On production, you probably don't see it.
Yeah.
With your workload, you won't see it. With your workload, probably it's like few percent only overhead. But in some cases, when your workload is just one or a few normalized queries and frequency is super high, you have a lot of vCPUs and they start like competing. This is high contention situation. In this case, just check it. And in terms of weight event analysis, PG stat statements didn't show up in weight event analysis until I think Postgres 16. because it was not covered by wait events, I think, right? So
Interesting.
maybe I remember incorrectly, but definitely it was not covered until some version, and then it started to be covered. So you can see it if you have very fresh version of Postgres, you can see it in for example, RDS performance insights, right? In this case, it's worth just removing it, but I think some guys have such kind of workload. It's not for everyone, quite rare, let's say. It's quite rare, but it's valid
Sure.
key value, right? Just selects. You need to serve a lot of, like, you need to respond very quickly using just B-tree, index search, just single row, super fast query, and then you have a lot, right? So just removing PGStar statements, you can get more. But so and this leads to question how to optimize PGStar statements. There is interesting discussion in Hackers. Let's just advertise it a little bit for those who are interested.
Yeah, for sure.
And another point I wanted to mention, you started this discussion on various clouds. Our bot knows already about price, about cost, so we could potentially check different machines on GCP and bring also AWS and start discovering, like, I want 1 million TPS, just selects where it's cheaper, which machine is it, like ARM, Intel, AMD, let's compare different clouds, different machines, where. It's interesting, right? I mean, performance cost.
I think so. I liked your transactions per second per dollar. TPSPD,
Yeah.
I reckon you should
And
go with.
starting from very simple trivial workload like these selects, and then maybe to extend it to closer to what you have, and then you can decide which machine is better for you.
This is something I've actually been struggling with. I think it could be really useful is how do you let someone know that their workload could be done on the next instance size down, you know, with maybe through a bit of optimization. But if people have a rough idea of their workload, maybe they know it's all OLTP and they know roughly like the average transactions per second, what size instance should they roughly be on? Like just a rule of thumb.
This is called capacity planning.
I know, but also I think so many people are so over provisioned because they're so undertuned.
Many people
that,
are under provisioned.
They
For
don't
example, I have
realize
cases when people that people already
Also true.
hit the ceiling for specific kind of platform. For example, Graviton on AWS, on RDS, for example, and you have already the biggest size. And maybe it's time to, I don't know, like, to scale somehow, or to take different kinds of machines, because you see how big Intels you have, but it's not available on RDS, of course, yet, right? But so I see cases both under provisioned, and maybe you're right, it's more common, and over provisioned more common, when you have like CPU like 5% maximum, right? And you pay for everything else, like, why? But I also see cases when it's already hitting ceilings, and it's time to do something about it, right?
Of course.
And maybe I see them because people go to us for consulting and help, right? So they don't go for let's well, sometimes we have this, like, let's optimize our spendings, right? But it's like, we mostly useful when you have problems with performance and how to grow further.
Yeah. Well, I see the opposite. I think not because they come to me, or because they come to us. It's more that I know friends, like founder friends and things, quite often the cheapest solution in the early days is double the instance size. You know, if you're going from $30 to $60 to $120, that there's not many engineering hours that can go into fixing that. But you might as well just upgrade and then worry about it later.
Or for example,
so I think I see quite a lot of that.
Like, became big fan of Graviton, ARM, right? And you decide, oh, it's great, and it's like checked performance, cost, great, but maybe it's not, like, it was good a year ago, but maybe not now, and things change very quickly, and different nodes, like instances, types of instances are added in cloud very quickly. So, what in ideal world we should have some rule how to find the best optimal choice for instance family and size. And also we should have great migration automation to switch, zero downtime, right?
That's the other thing. I think people are scared. People are scared of going back down.
Test, and then switch. Everything is possible, but requires some effort, unfortunately. So, good. 4 million TPS, almost.
Almost, yeah. Or 6 million. I'm going with 6 million TPS.
And maybe someone already has this machine with almost 900 vCPUs and they can show us 10 million or something.
I'd expect more.
Maybe. Yeah, 10 million TPS, next milestone for Postgres on single node. Great. Yeah, by the way, final note, I tried to find information about MongoDB. I asked guys, like, I found only like some slightly outdated benchmarks, like 3 years old or so. And I didn't see anything above, like, from single node. I even didn't care about if they have transaction mode enabled or no, right? Because they can cheat here, right? But I didn't see 4 million. I saw only 2 million, 2.5 million or something TPS, that's it. So I think Postgres is very competitive
Good to
in
know.
this area. Yeah, okay, good.
Nice one. Cheers, Nikolai. Catch you next week.